Okay, let's take a look at 93, restore IP addresses. So we're given a string containing only digits. We're going to restore it by returning all possible valid IP address combinations. Okay, let's take a look at here. We have a string containing only digits, right? And we're going to restore it, which is by returning all the possible valid IP addresses, right? So we have this IP address and we have this IP address, right? Okay, so how do we solve this problem? So first, we need to figure out the definitions of valid IP address, right? So what is a valid IP address? So first, when we see the example here, we know for each valid IP address, we have a total of 4 parts, right? And for each part, actually, we have at most 3 digits in each part, right? And so the maximum number of digits in each part is 3. So another thing that example doesn't tell us is that so the minimum number of digits that we can have for each part is 1. Okay, so let's see, we can have this. This is also a valid IP address. We also can have 1, 1, 1, 1, 1, 1, and 1. So this also is a valid IP address, right? So now we know what is valid IP address. And another thing that we should note that, which is for the 3 digits part, the numbers should not be bigger than 255. So if it is bigger than 255, that's not valid anymore. Okay, so now we get clear about the definition of validation about the IP address, right? Let's think about how we solve this problem. So if we have a string, how do we find all the possible combinations for that a valid IP address? So for this problem, we can use DFS backtracking algorithm to solve this problem. So yeah, you probably wonder how do we use DFS backtracking, right? So let's take a look at this example. It will help us to understand how the DFS works for this problem. As we said, we have 4 parts for the IP address, right? Let's say we have index 1, 2, 3, 4, right? For index 1, which means the part 1, right? For the part 1, we can have 3 choices. The first choice is that we can choose 1 digit. Another choice is that we can choose 2 digits. And the third choice is that we can choose 3 digits, right? Okay, so for the part 2, if we choose 1 digit as for our part 1, right? For part 2, we also can choose 1 digit, or 2 digits, or 3 digits. 552. Okay, so let's take a look at here. So if we choose 552, it is much bigger than 255, right? So it means that which is not a valid option for us. We're going to delete or abandon that choice. But let's continue to our part 3. If we choose digits for part 3, we still have 3 choices. We have 1 digit, right? For here, we have 1 digit, we have 2 digits, we have 3 digits, right? Let's continue. We also, for the part 4, we also can have 1 digit, or 2 digits, or 3 digits, right? Okay, let's take a look at this path, 2552. That's our 4 parts of an IP address, right? However, it is not valid IP address. Why? That is because this string actually we have 12 digits, but here we just used the first 4. It means that we haven't used the rest part of the string's elements, right? So for this question, we need to use all of the digits in the string. So it's not a valid IP address. Anyway, you get an understanding about how the DFS backtracking works, right? So yeah. So for each part, we have 3 choices, and we go after we make one choice, we go deeper to the second part of the IP address, and we make choices either 1 or 2 or 3 digits, and then we go deeper to make choices, and until we reach at the part of 4, we make choices, and we check each of the path if it is a valid IP address or not. If it is, we add to the result. If it is not, we just go back to see if we choose another choices is going to be a valid or not. That's all. That's how the DFS backtracking works. Okay, let's write code for this problem. So first, we need to have a data structure to store our final results, right? Okay, and then we need to have a base case to do some base case, right? Check. So if s equals none, or the s then length smaller than 4, like we said, right? Or if the IP address is bigger than 12. Okay, here we need to take a look at here. So why 12? It is because for each part, at most we can choose 3 digits, right? So we have 4 parts. It means that 3 plus 3 plus 3 plus 3. So the total digits that we have for one valid IP address, which is 12. So that's the maximum digits we can have for a valid IP address. Okay, so if our case is one of them, we just return result. Okay, then we can do our DFS and return result. Let's take a look at the DFS function. Okay, good. So we pass our string into it, and we pass our substring into it, which is the empty string, and we pass our index. It means that we have 4 parts to finish the valid IP address, right? And finally, we pass our result into it. Let's see here. Cool. Let's do base case check. That means that when should we stop our recursion, right? Okay, let's take a look at here. If we want to stop our recursion, it means that we reach the part 4, right? So it means that if our index equals equals 4, right? We can stop. And or we used all the digits in the string, right? Okay, so either one of the condition satisfied, we can return. But when is the time that we can add to our result, right? So here it is. If our index reach to 4 and as the length equals 0, then we can use our result to add the result to our list of string result, right? Okay, here, return. We're going to fill this part later, but first, let's take a look at this part. So remember, we have 3 cases, right? The first case is that we can choose 1 digit, right? So when can we choose 1 digit? It means that we just use one size of our substring, one size of a string as a substring, right? And a substring and as the substring 0 to 1 and add the index plus 1 and result. Okay, we finish this case. Let's talk about case 2. We choose 2 digits. So when can we do the case 2? So we need to satisfy 2 conditions. The first one is our length of string actually is bigger than 1. So if the length is smaller than 1, it means that we do not have 2 digits in the string. That means we cannot choose 2 digits, right? So the length must be bigger than 1. And the first digit cannot be 0. So there is another valid conditions for making a valid IP address. This means that for each part, the first digit cannot be 0. So here cannot be 0, here cannot be 0. Neither here or there. Okay, cool. And then we do DFS, then substring size 2, substring 0 to 2, plus the 2, 1, result. Cool. Okay, we have our final choice, which is we can choose 3 digits. Okay, so why write the DFS at here? It's because if we are going to choose 3 digits, our length must be bigger than 1, right? And the first digits cannot be 0. And our length actually should be bigger than 2. And the integer, the value of destined substring 0 to 3 must be smaller or equal than 255. And then after we satisfy all the conditions, we can do the FS. As the substring size 3, sub plus as the substring 0 to 3, and plus the our index plus 1 and result. Okay, so here we finish the main part of DFS functions, and we need to add the result, right? So sub then substring starting from 0 to sub the length minus 1. Okay, you may wonder why we subtract 1. That's because we actually add dot after each substring, right? So it means that we have dot after size 3 substring, and we'll add dot after size 2 substring, right? So if we do this part, it means that we have dot at the end of this IP address. But if it is a valid IP address, we do not need to have a dot at the end of this part. So we need to delete it. Cool. And here we need to finish this part. Sub, which is empty, and 0, and result. Okay. Yeah, I think finish the code. Let's see. Yeah, I think everything's cool. 2, 1. Okay, let's run the code. Oh, okay. Nice, accepted. Cool. Okay. Thank you for watching.